So today we will be combining resistors, lamp as a testing device, a capacitor, and a diode, of course, along with the EMF. So here is the circuit. Here is the EMF. I put here a switch. So for the first time also, I'm gonna draw down here. This node is the most common node. We call this the ground. So now we have seen this on this node. We have seen we have the ground here, and on this direction, I'm gonna put the bulb as a testing device. So here's the bulb. I'm gonna put the diode here. So how do we recognize that we have a diode? You have two sides that to think that you have to look at here. The bottom line here, this is just like a line, like a single electrode. So this is the side, the negative side, that will not allow the current to pass through. And so that means the positive side is here. If you go from positive to negative, that's the direction of the current. The current is moving in this direction. Let's call this ID, current passing through the diode. So remember that if we go back to the EMF, the longest electrode is positive and the shortest electrode is negative. So I'm going to close this way. Let's put here a resistance. Maybe you're gonna put also here another resistance, and this will be attached to a capacitor. So here is the capacitor C, and we're gonna attach this to the ground, the other part of the capacitor. So let's call this, so this is the EMF. In this case, I'm just drawing a sketch showing those capacitors, bulb, diode, and two resistors, R1 and R2. And then I will explain briefly, this is K, the switch. I will explain briefly what's going on in this case. So let's say, for example, that if you have to draw, let's put some numbers here, some label. Let's label the ground G. So this is ground. This side over here, let's call this A. This node is A, this node is B. So this node is C. C red is the node, but the C black is the capacitor. Then you go back to G here, down here. Okay, so if we draw the electric current, what would be the electric current? Again, just to remember that you can make an analogy with the water pipes and the water inside. So the electric current is going out of the positive sign. So I will label this as I sub naught. So I sub naught means the principal electric current. Then this is passing through R1. So we are still I sub not here because there is no over directions to go than passing through R1. Now when we reach B, we will have one part of the principal current passing through this. I would write it as I2, through the I2. So going this way, I2. And the other one passing through the diode, which is right there. So we call this ID. And then if the current is passing through the diode, it will light the bulb here. And then coming back to G, so from this side we get back the I sub naught, the principal current, and on this side the I2. Then we form a loop coming back to the EMF, the source of power. Now let's see a different case here. For example, let's say number one, case number one, if K is open, what happens? Case number two, K is closed. So we follow this step by step. Number three, K is open. And we will do some analysis of all of this. So with regards to the lamp, what's going on in this case with regards to the lamp? Okay, so case number one, K is open. So K is open. If K is open, there is nothing here. There is no current. No current passing through. No current passing through the diode. So that means the lamp is not lit. It stays unlit. Now on the other side, of course, the capacitor is not allowing anything to go through. There is no charging even. So that means I will just write about the lamp. So we will make a two statement. If it is lit, then we're gonna write yes. If it is not, then we're gonna write no. So for now, there is nothing here. Second case, we close the circuit at the K level. The current is passing through. Current is passing through. This is passing through the diode, of course, because the diode location is that you have the plus sign here, and the direction again is positive to negative. So positive to negative through, so the current passes through. And that will lit this lamp here. So we can say yes. Now, the other thing at the same time that is happening is the other part of the current is going through R2, and this is not populating the plates of the capacitor. So the capacitor is charging. We have positive on this side and negative on the other side of the plate. So this is charging. Capacitor is charging. Then what we have to do next, we have the I0 coming through, making the loop. Now, next step, we're going to open K. So now we're going to open K. So now this is no longer connecting. So we have no sources of power here. So what's happening in this case? The current, the charge that was stored here, the charge that was stored in the capacitance here, this is discharging, so taking a new current that I call the IC. A new current is passing through, and since this part is cut off, there is no directions here. The current has to go through the diode, and we still have the plus side here. So that means this will go through, and we have a lamp here, lightning. So the answer here also is yes. So this is a sample. We don't do any calculation yet. On the second part, I do some calculation, but just to understand what's going on in a circuit. What's going on in a circuit? If you have a capacitance, the capacitance, remember that the capacitance is, remember the formula for capacitance, V. So V is the potential at the edge, at the two tips of the capacitance, potential V equals Q, the total charge, divided by C. So C is the charge of the capacitance, so that the capacitor, what you call the capacitance. So this is expressed in farad, F, and Q is the charge. So Q is a charge, so Q is in coulombs. I know that there are some many letters here. C here is capacitance, C here is coulombs, but you need just to make sure that you are talking about the capacitor or you are talking about the charge, which is the unit. So we have to now in, for example, the capacitance of the capacitor in farad. Knowing the voltage, if we know the voltage between point C and the G, the ground here, and then we can determine the charge. So this charge is the charge stored in this capacitance here during the charging process. We can reach the maximum. You can reach the maximum if you know the capacitance and the voltage, then we can have the total charge here. But once you start charging the capacitor, then you are storing a few coulombs, and it is increasing until you reach the maximum charge. So that's it for this figure here, and I will show you next time some things similar, but this time with calculations.